that we have been able to create that retention index to retention time mapping, let's go back to the original goal. There's a number of ways to use this scenario. Unknowns analysis, which I think you can envision as very powerful with retention indices in the flavors and fragrances business, for example. We have perceived compounds, where when you're doing library searching, you can use the retention index to help you constrain that library search and get a better, higher quality fit. And last, I'll show you the idea of automatically creating a quantitation method, and we'll use library search, but library search with retention indices. Now it's time to really apply this technology. I've got a new injection that has, I believe, some pesticides in it, and I'm going to demonstrate this technology by using new method from acquired scan data with library search. So it will use the library search, look through and find compounds and create me a quantitation method, very similar to the thinking behind unknowns analysis. So here I go. I'm going to point it to the library that I've got. I'm going to pick that file that has the pesticides in it, and I'm going to go to the advanced here, and as I look through in the library search tab, I need to make sure that it's pointing to the retention time calibration file that I've created. So in that case, it's my last try, which is 9, and I'm going to let it fire off. So it's going to take that data file, it's going to go through and deconvolute the scan data, pulling out those spectra one at a time, and then when it's got those spectra together, it's going to go over to the library using not only the spectral match criteria and constraints, but also with the retention time and the retention time to retention index mapping, using that criteria in the retention index window to come up with a list of compounds. So there it's finished with deconvolution. Now it's going to run through the library search and pick out those matches. And it's going to show us a list of compounds that it's found. So let me sort those on library match score. And if I look here at this set of compounds, I can see it's found some pesticides to create this method here. And if I look at the other columns that are associated with it here, I can easily see that there's the retention index, there's the library retention index that's associated with each one of these compounds. It's found the CAS number, and it has a nice library match score. So that demonstrates the use of retention indices, and I think with just a bit of extension, you can envision going through with unknowns analysis in the flavors and fragrances industry and using this technology to look for things that you have in your own custom library using retention indices as a constraint as well as a spectral matching. Thank you very much.